Hi, this video I'm going to talk to you about the Pmcc, So that stands for Product Moment Correlation Coefficient. Product Moment Correlation Coefficient. It's quite a lot, isn't it? That's why I abbreviated to Pmcc. Sometimes called Pearson's Product Moment Correlation Coefficient, named after Carl Pearson, the statistician. Okay, he came up with this. And what's it all about? Okay, well, it's determining really the strength of correlation. Remember, I've talked to you about that in a previous video. So, for example, in these scatter graphs, we might have said that looks like it's a fairly strong positive correlation, and that might look like a reasonably strong or weak correlation. Okay, but in comparing the two, I'm sure you'd agree with me, this one has got a stronger correlation. Okay, however, it depends on quite a few more things, doesn't it? Okay, how about the scaling? Okay, I might use a different scale for this graph as I do for this graph, okay? And so I might have done that purposefully to make you think that's a stronger correlation, whereas in fact that might be the strongest one, okay? What if we zoom in or zoom out, okay? What if I've zoomed out of one of these graphs? Well, of course, if I zoom out and I overlay the line of best fit or regression line on the points, it's going to look like the points are fairly scattered, far away from the regression line. Whereas if I zoom in as much as possible, it's going to look like the points are closer. Okay, so what I'm saying is you cannot just look at a scatter graph or two scatter graphs and know with 100% certainty which one's got a stronger correlation. This is where the Pmcc comes in. Okay, this is where Pearson did a lot of very good work. Okay, what it does is it gives us a mathematical formula for calculating a strength of correlation. How about that, eh? How about that? That's fantastic. A mathematical formula that allows us to calculate the strength of correlation. Okay, that's the sort of things I like. I love precision in mathematics. That's one of the reasons why I'm a mathematician. Okay, and why I prefer the pure side. Okay, and what I like about the Pmcc in statistics in particular is it looks at the precision aspect. There's a formula that we need to use to calculate an actual value of the Pmcc. Okay, that's one of the things I like about statistics, the precision element of it. Okay, the formula is quite simple, but before I give it to you, okay, let me just introduce the letter R for you. R is what we use to represent this correlation coefficient. Okay, and traditionally the value of R lies between -1 and 1. If you want, you can write it like this: the modulus of R is less than or equal to 1. Means the same thing. Okay, so when we get our formula, which I'll show you what that is in a minute, we're going to calculate a value of R. That is the Pmcc, the correlation coefficient. It's just a numerical value, no units assigned to it at all. A bit like gradient in that respect. There's no units assigned to gradient. A gradient can be positive or negative. Okay, or it's a bit like the coefficient of friction. Okay, if you've done that in mechanics, there's no units attached to that, but traditionally coefficient of friction starts at 0 and then it gets higher. Okay, it's got no units, but it lies between -1 and 1. Okay, and one of the really great things about this is that it's so simple to interpret. Basically, the larger the value of R, the closer it is to 1, the stronger the correlation, and it's positive. Okay, the closer R is to 0, the weaker the correlation. Okay, or there's no correlation if you've got R is close to 0. Okay, the closer R is to -1, the stronger the correlation is, but negative. That's quite simple, isn't it? Okay, so let me just give you a few examples. Okay, so let's just compare a value of R equals 0.9 with a value of R equals 0.3 with a value of R equals -0.7. Okay, so we've done the Pmc formula, for example, and we've got these three values for different sets of data. How to interpret this? Okay, so first of all, that's positive, that's negative. Okay, second of all, that one's fairly close to 1, so we might say that's a very strong positive correlation. Okay, however, this one, okay, it's much closer to 0, isn't it? Okay, and we normally say that if a value is about 0.1, 2 or 3, then we say it's close enough to 0 to say it's got no correlation. Okay, so we say no correlation without, it doesn't have to be bang on 0. Okay, the formula calculation is precise, but the interpretation, we've got to allow for a little bit of leeway, haven't we? Okay, so we say around about 0.3, 0.2, 0.1, 0, okay, negative values as well, then we say it's got no correlation. That one there is closer to -1, okay, and it's negative, because it's negative 0.7, it's not as strong as that, so it's a reasonably strong, possibly even a moderate strong negative correlation. So that's how we'd interpret them, okay. But I do like the Pmc formula because it gives us a nice way of actually working out just how strong a relationship is without actually drawing the graphs and all the points, because let's face it, drawing these out all the time is time consuming, isn't it? Okay. Here are the formulae then. Oh wow, look at that. You didn't expect it to be so complicated, did you? Well, I'm sorry, yes it is, okay. Let me just break it down for you a little bit though. So if you've seen the least squares regression line already, which I'm hoping you have, then these formulae, they're not new to you, are they? Okay. You recall SXY, SXX, SYY. If you've not seen least squares regression, do it now because it makes sense to do it that way. But if you really don't want to do it now, then I'll just remind you about this. You probably saw that when you did the standard deviation. Remember the standard deviation, you do that divided by n and then square root it. So you have seen these before, okay? Well, the formula for the Pmcc is simply that I've highlighted for you, okay? Let me just zoom in a little bit more for you, okay? So you've got R, your coefficient is calculated by doing the following: SXY on the numerator of the fraction, and then on the denominator, square root of SXX, SYY, okay? That is it, that's your formula, okay? I'm not going to prove that for you. If you're interested, you look that up yourself. You can do some things yourself, can't you? Okay. But what I'm going to do next is show you a simple example in how it works, and it really is quite simple. So here's an example. Okay. So we're given these summary statistics here involving variables x and y. From those, we need to calculate the Pmcc. You can see why this is linked strongly with the equation of the regression line, can't you? Because we'd use something similar to this to start off with an equation of regression line question, okay? And linked together in one question, you could quite easily have a scatter graph, find the equation of the regression line, interpret the equation of the regression line in terms of the gradient and the y-intercept, use the equation of the regression line to make some predictions and calculate the Pmcc. All that together makes quite a nice A-level mathematics question, actually, okay? But anyway, let's get on with this. So as a reminder, this is how we calculate the Pmcc, our value of R. So we've got to work out SXY, SXX, SYY first, okay? So let's go ahead and do that. So I'm going to work out that one first, SXY, just because it's on the numerator of the fraction. So that's sigma XY, so it's there. So 9,915.3, and let's subtract sigma X, sigma Y, so that times that, 176.9 multiplied by 679 all over the value of n, which is, oh gosh, what's the value of n? So I forgot to make a note of that when I was doing the question. The value of n is 15. Okay, beg pardon. So value of n is 15. Yeah. You soon get stuck because you'll soon see if you've not got all the data available, okay? What you would do, of course, in this particular scenario is, just as I did, read the question again because we need a value of n. If a value of n was not given to you, then there'd be some reference of it somewhere. For example, there'd be a table of values with 15 paired data items, okay? And you just add them up to make sure you got n is 15, okay? So there's some way of actually doing that, okay? I could say I did that on purpose, but I think we both know that I didn't. Okay, so I say both, that implies I've got just one viewer. I'm hoping to get more than one viewer, okay? Imagining that's not going to work out to be a nice value, okay? When I say not a nice value, I mean, well, we'll see, 176.9 multiplied by 679 divided by negative 15 added to 9,915.3. That face says it all, doesn't it? Not a particularly nice value. So I've got 143,072 over 75. Yes, I checked the decimal equivalent and it's not much better, to be honest. At least I know that's an exact value, the fraction there. So I've got that, okay. Next I'm going to work out SXX. SXX. I like saying SXX, not for the reason that you might think, because I'm from Essex, you see. There's a county in England called Essex, that's where I'm from, okay? And quite often when I say Essex, it reminds me of Essex. It's just a personal thing to me. Whenever I talk about SXX, I'm always thinking of home, you see. So you might see me have a little smile every time I say SXX. But I have to say X, it's not for the reasons that you might think, okay? Right, so SXX, sigma x squared, so that's 2,576.47, subtract sigma x all squared, so that's 176.9, better put that in brackets I suppose, squared over the value of n, which is 15, and we'll see what value that gives us. Okay, so that should be, my camera looks tilted, so just because I had a wobbly moment earlier and I filmed a whole segment and the camera wasn't facing me, I had to go and do it all again. That was kind of annoying. So my camera just looked at a funny angle for me. So it's 176.9, so square that, divided by -15, and then add 2,576.47, okay, an even nastier looking number. So this is kind of why I use fractions. 183,836 divided by 375, okay, and the decimal just looks even nastier, okay. So that's that, and then SYY is next. Okay, so sigma y squared, that's that, so 39,771, subtract sigma y all squared, so 679. Don't need to put that one in brackets. I only put that one in brackets incidentally because it's a decimal, traditionally a decimal fraction. Should put in brackets squared, but with integers I tend not to. Okay, negative values as well, you should put in brackets as well. And divided by n, which is 15. Okay, and I'm just going to work out what that is there, okay? So, 679 squared, press the wrong button, divided by 15, and leave it negative, add on 39,771, okay, oh, slightly nicer number, but still all right as a fraction. Let's just put that safely there, shall we? So that's 135,524 all over 15. Okay, and that's lovely, isn't it? Okay, just going to pause the video because I'm going to tidy up the board, so I've got the next line of working ready to go in. Okay, don't go anywhere, I'm just going to pause it. Okay, so I've tidied my board, made some space. This is where my classroom comes in handy because I've got really nice big boards, 2 of them, okay, that I can actually use without rubbing them off, okay. So I apologise for having to do that in this video, but you can always rewind, can't you? Or maybe you're taking notes as we go along. So we've got to there, SXY, SXX, SYY, and we're going to work out what R is. And remember, R is going to be SXY over root SXX, SYY. Okay, so calculation R is equal to, now, because of the awkwardness of the numbers, let's face it, they're awkward, okay, I'm not going to actually write in the formula, okay. What I'm going to do is I should specify, what I'm going to do is I'm going to write the actual formula, but I'm not going to substitute the actual values and have them written in, okay. So in other words, I'm not going to just write out R again with that in there, that in there, and that in there. I'm just going to tell you that's what I'm doing. Okay, I'm hoping that's good enough, and that'll be good enough for the examiner as well, okay, for the method mark, okay. If I had time, and I'm talking about at least a minute because it's going to take a minute to put those in, I might just write it in, but for the moment, just for the video, I'm not going to. Suffice it to say, the first thing I'm going to do in my calculation, I'm a bit old-fashioned with how I use my calculator, okay, is I'm going to work out what that times that is. So that multiplied by that, so let's just do this, so 183,836, okay, and divided by 375, so that's the first one, and then multiplied by that, 135,524, okay, divided by 15, it gives me a number, and then I'm going to find the square root of that, okay, square root of that number equals, something awkward, again, it won't even let me write this one as a fraction this time, that's how awkward the number is, okay. It might be because it's a irrational number, if thinking about it actually. Okay. Hooray, irrational numbers, pure mathematics. Okay, so I just thought I'd get that in there. Okay. So what I might do is, rather than write that all in, do that initial calculation, okay, and put in that the denominator I know has got to be this, 2104.56393. Let's put a dot there, shall we? Okay. And then on the top, the SXY, up to you. I mean, should we put that as a decimal, or should we just, I can't remember what the decimal is now. I'm just going to put it in as the fraction we see, 143,072 over 75. The trouble with decimals is, okay, there's a rounding element that goes on. Now at the moment in my calculator, I've got the exact value of that, okay? But imagine I rounded that as a decimal, and then put them all into this. Okay, the answer is going to be inaccurate, and as I've mentioned already, I do not like inaccuracies. I don't like inaccuracies. I love accuracy. Okay, that's why I really like pure mathematics. Okay, pure mathematics to me is, the absolute king. Okay, if mathematics is the queen of the sciences, then pure mathematics is the emperor, or whatever you want to call it. Okay, so what I'm going to do is I'm going to put in the reciprocal of that. So that's going to be, I don't have a reciprocal button for my calculator. That's the only negative thing about these calculators. There's no reciprocal button. So I'm going to put power of -1, and then I'm going to put multiplied by 143,072. Okay, yep. And divided by 75, and then type in. So 0.9064, and I know that the number I've got in my calculator is 0.9064237,192. Hope you've got the same, is the precise value. Okay, I know we're going to round it most likely to 3 significant figures, 0.906. Okay, but I do like the accuracy bit as well. Okay, so that's our answer. That's what the Pmcc is. Okay, interpreting it. First of all, when you check your answer, make sure it's between -1 and 1. You know you've made a mistake if your answer is not between -1 and 1. Just as when you're trying to calculate a probability of something, you know you've made a mistake if your answer is not between 0 and 1. Okay, so make sure your answer is between -1 and 1, which it is. So the likelihood is things have gone well for you so far, and then you can interpret it. Okay, that looks like a very strong positive correlation because it's 0.9 something and it's very, very close to 1, isn't it? Okay, so that's it. I'm hoping you found that example on the Pmcc helpful and useful to you. The next thing to do, of course, is to practice as many questions as you possibly can. Okay, I'll see you again.